Okay, in this video, we're going to talk about velocity and net change. So basically, it comes down to this formula. When you integrate any kind of a rate of change, what you'll ultimately get from that is the net change. Okay, so let's look at an example. We have Mr. Brest is driving across down to Mr. Sullivan's. His velocity is given by this function here, which we see as graphed here. Notice that his velocity is negative at some points and positive at others. So we want to answer these questions. How far is Mr. Brest from his house after 10 minutes? What is the net change? So notice on the window here, we need to get these tick marks. So it goes from 0 to 30, and the tick marks are increments of 5. So this would be 5, 10, 15, 20, 25, 30. And we don't necessarily need to know the y-axis tick marks on here. What we want to know is how far is Mr. Brest from his house after 10 minutes? So that means we want the net change, the net area under the curve from 0 to 10. Now remember, this area that is below the x-axis will be negative. But the way we write this would be we'd write the integral from 0 to 10, and we just put the v of t in here. Of course, we're integrating with respect to time. Now, for this particular problem, it says use a calculator to solve. So we can do this. Let's go ahead and open up a Desmos window. Do a graphing calculator here. What I'll first do is define the function v of t. This is going to be the sine of 0.3 times t plus the natural log of t plus 1 minus 2. What I can do is I can adjust the window here, and I'll use the same numbers that were given. So I'll go from 0 to 30, and the step will be 5. And then on the y-axis, I'll go -3 to +3 with a step of 1. Okay, so we get the graph here. What I can do is in Desmos is now I can integrate it. I'll type int, and give me the integral sign. We'll go from 0 to 10, and now I can just do vt dt. And it will go ahead and do that integration for me. And we can see that's 3.01. This is in units of miles. Since we have miles per minute, remember we're finding the area, so we're going to do the units on the y-axis times the units on the x-axis. So miles per minute times minutes gives us miles. So that's 3.01 miles. And this is an approximation because we did round that off. Okay, how far is Mr. Brest from his house after 15 minutes? Well, then we go here and we include all of this little area here and this. Again, 0 to 15, v of t dt. And again, we'll use the calculator to do this. We can go ahead and plug it in Desmos, int, 0 to 15, v of t dt. And you see we get about 3.40 for rounding to the nearest hundredth. So 3.4, again, an approximation, 3.4 miles. I guess we'll go ahead and put boxes around these. 3.4 miles. Okay. And finally, if Mr. Brest arrives at Mr. Sullivan's house after 30 minutes, how far away does he live? So that means then we'll just go ahead and integrate the entire area under the curve, the net area under the curve, of course, between 0 and 30. 0 to 30, v of t dt. Again, typing this into Desmos. 0 to 30, v of t dt. Get 22.82 miles. All right. The last question for this problem is how many miles did Mr. Brust drive? So how many miles total? So what we actually want to do then is we want to integrate the absolute value. So these negative parts will actually flip up onto the positive side. The way we'll write this is we'll do the integral from 0 to 30 of the absolute value of v of t. Now the absolute value of v of t is the speed, not the velocity. The absolute value of the velocity is the speed. So and we can again do that in Desmos. First of all, we can take this and we can put absolute value signs around this to show how this would look. And you see it just flips those negative parts up onto the positive side of the x-axis. And then, of course, it'll change all these answers here. So let's keep that as v of t there, but let's now do the integral from 0 to 30. And we'll put in the integral sign, we'll put the absolute values. I'm going to grade this. We see that it's 28.50 miles. 28.50 miles. So he traveled a total of 28.50 miles, even though Mr. Sullivan only lives 22.82 miles away. But what we see on the graph is that he traveled with a negative velocity, he traveled away from Mr. Sullivan's house for a bit, a couple times there. So he ended up driving a little farther than he had to. Okay, for this next part, so let's deal more specifically with velocity. So if we integrate the velocity here, we just the velocity, we basically then get the displacement, how far from the initial position the object moved. If we integrate the absolute value of the velocity, which again is the speed, then what we get is we get the total distance. So the displacement versus the total distance. Okay, so let's do example 2. A particle's velocity is given by this function. If x of t represents the position of the particle along the x-axis, we want to find the following. So we want to find the position of the particle, that is the displacement, after 3 seconds if its initial position is 5. So the way we'll do this, say the position starts off at 5, right? So we have the initial value, and then we will integrate the change between the displacement between 0 and 3. So it starts off at 5 at time equals 0. And then we have a change. So we have the initial value plus the displacement. And that will give us the position after 3 seconds. So we'll have, this is t cubed minus 2t squared plus 1. And we integrate with respect to t. Okay, we'll go ahead and do this one manually. So we'll have the 5, we'll leave that there. Now, when we integrate t cubed, we can split this up into 3 different integrals, or we'll just do it all together here. We get plus, this becomes t to the 4th over 4 minus 2t to the 3rd over 3 plus t. And we have to evaluate this between 0 and 3. Okay, so this gives us 5 plus, and now we'll substitute in the 3 here. This is 81. We'll have 81 over 4 minus 2 times 3 cubed is 2 times 27, or 54 over 3 plus 3. And then we'll subtract, we'll evaluate this at t equals 0, which means we'll subtract 0. Okay, so we have 5 plus 81 over 4. 54 is divisible by 3, and that's 18. So I'll have 5 plus 81 over 4 minus 18 plus 3. 5 plus 3 is 8. 8 minus 18 is negative 10. So we have negative 10, or we can get a common denominator, would be negative 40 over 4 plus 81 over 4 is equal to 41 over 4. So 10 1/4 is where the particle's position is after 3 seconds. Okay, for this next problem, we'll find the position of the particle after 2 seconds if x of 1 equals -2. So its position at t equals 1 is -2, and we want to know the position of the particle after 2 seconds. So what we'll do here is we'll say, again, we'll take its initial value as -2, and then we just want to find its displacement between 1 and 2. So, and that'll tell us where its position is at t equals 2. So again, we have the velocity function here, t cubed minus 2t squared plus 1. We're integrating with respect to t. Okay, so we have -2 plus the same antiderivative here, t to the 4th over 4 minus 2t cubed over 3 plus t. In this case, we're evaluating between 1 and 2. So this gives us a -2 plus 2 to the 4th is 16. 16 divided by 4 is 4. This would be 16 over 3. So minus 16 over 3 plus 2 minus, we'll have 1/4 minus 2/3 plus 1. Okay, we have a -2 plus 2. We'll cancel those out. We have a +4 minus 1 gives us a 3. Then we have minus 16. We have minus 16/3 plus 2/3 gives us a minus 14/3. And then we have the minus 1/4. Okay, so we'll get a common denominator will be 12. This will be 36 over 12. This is 56 minus 56 over 12 minus 3 over 12. And we get 36 minus 56 is -20. -20 minus 3 is -23 over 12. And that's its position. Okay, finally, last example here, example 3. What is the total distance traveled by a particle during the first 4 seconds if the particle's velocity function is given by -2t plus 3? I'm going to show the setup and the work. So basically, for the first 4 seconds, we're going to integrate this, but we want the total distance traveled. So we'll actually take the absolute value. So we want the integral from 0 to 4 of the absolute value of -2t plus 3 with respect to t. Notice that at 1.5, 1.5, 3 halves, that this is 0. So we need to split this up into 2 integrals. We need to go from 0 to 3 halves. Where the function is positive, we can just then do the integral -2t plus 3 with respect to t. And then what I need to do is add the integral from 3 halves. I'm doing a decomposition to 4. And then since it's negative here, I need to multiply it by a negative. So it'll be 2t, positive 2t minus 3 with respect to t. Okay, so now we go ahead and integrate this. The integral of negative 2t is negative t squared, right? It's negative t squared, negative 2t squared over 2, so the 2's cancel, plus 3t. We'll evaluate this between 0 and 3/2. And then here we have t squared minus 3t between 3/2 and 4. Let's go ahead and do this evaluation then. 3/2 squared, we'll have negative 9/4 plus 9/2 minus 0. We substitute that in, we'll get 0. Plus, over here we'll get 16 minus 12 minus 9/4 minus 9/2. Okay, 9/4 plus, this would be 18/4. That would give us a positive 9/4. 16 minus 12 is 4. 9/4 minus 18/4 is a minus. So we'll have minus from that. Then we'll have a negative 9/4. So 9/4 plus 9/4 is 18/4. And plus 4, we'll get a common denominator, 16/4. So this gives us 34/4, which reduces to 17/2. And that is the total distance traveled by this particle, again integrating the speed, which is the absolute value of the velocity. And that's it.